Okay, so let's carry on with the problem I finished up with last time where we calculated delta S for the reaction, but I've gone through here and I've divided it by down to 1 mole, and so this would actually be 1/2. And that means I would divide delta S by 2, and I want to find out if this reaction as written is spontaneous. And so I have a delta H, and I have my delta S. Delta H I looked up on the table, and here I notice that this is in kilojoules and this is in joules. So I need to convert this to joules. And so negative 326.6 joules per Kelvin, and there's 1000 joules in 1 kilojoule, and so this becomes negative 0.326.6 kilojoules per Kelvin. Okay, so now delta G is just going to be, the equation is delta G equals delta H minus T delta S. And so putting in our values, we have negative 237.1 kilojoules, and that's per mole. And this minus T, and this is temperatures at 298 Kelvin, so 298 times negative 0.3266 kilojoules per mole times Kelvin. And so now I'm ready to get out my calculator, turn it on, and so I'm going to take negative 237.1. Oh, you can't quite see that. Let me move it like this so that we can see what we're doing. Okay, and I have minus 298 times negative 0.3266 equals so I have negative 237.1 minus 298 times 0.3266 equals, and I get negative 334. This is only to the tenths, so I can only know this to the tenths. So my answer is going to be 0.4 kilojoules per mole. And this gets rid of my kelvins. And so since this number is negative, it is spontaneous. I hope that helps. Let me know if you need something else. I think this concludes everything you need for 7.5 parts 1 and 2. Thanks.